No, it has nothing to do. It was because I was tired last night. Literally, that's why. Let me just walk you through a couple quick things, and we're going to jump in. We're going to do a little warm-up problem with a little story time, and then a lab. We're going to do a bunch today, and it's Thursday, so it's going to be great. Really quickly, I just want to let you know we are starting Unit 7. It's rotation. It is going to be the last unit of this trimester. It is kind of a long unit because it's one of those funny things where it can either be like 2 really short units with tests at the end of each, or a longer unit with like maybe a check-in sort of thing at like partway through. Does that make sense? So on the calendar that's up on Canvas, that is the calendar that I used last year with the dates adjusted. It is not set in stone by any stretch, not that a calendar ever is in here, right? Like, let's be honest. But I just wanted to give you a sense of like how much homework there is and all that sort of thing. And then know, like I said, that we'll add a couple of like little quizzes, not like full period quizzes, but some like check-in sort of things. That seem fair to you? But this will be our last big unit before the end of the tri, which ends at the end of February, and then we'll move on to the third trimester of physics. Oh my gosh. I do not have your tests done. I will get them done maybe tonight if I'm really productive, fingers crossed, and my kids go to bed fast. We've got a warm-up question. You're going to take a lot of notes today. Not a lot, like a few. So you need some paper out. The question is up there. It's a pretty straightforward one. I'm going to leave you a moment or 3 to write it down. Got you. Okay. All right, my friends. We are going to regroup because I think we're either done or not done because we haven't really done it. So we're going to do it now. All right. It's a simple question, but that doesn't necessarily mean it has a simple answer. The question is, what does it mean for something to be in equilibrium? What did you come up with? Back table, what did you guys come up with? When the net force equals 0. Okay. Am I frozen? When? What else did you guys come up with over there, Emma? When things are balanced. What'd you guys come up with over here? The same of those two? Nothing new? What's that? I just didn't hear what you said. When they're equal, when they're balanced, I'll put equal. Okay, okay. Josh, you guys come up with other stuff? Okay. When a quantity has a net change of 0, my friends over here, balanced. Okay. That's great. All right, follow-up question. I didn't actually type it there. Give me some examples of things that are in equilibrium. I'll give you 30 seconds to write down a list, and then I'm going to go around the tables one more time. What you come up with? Things that are in equilibrium. This. Back we are. From our Skittles conversation, back to physics. We'll have this conversation later. I'm excited to have it with you, but not right now. I need some examples. We're going to go backwards in time, and I need to talk to somebody different at each table, okay? So somebody that was not the person I talked to just a minute ago. So somebody else said balance. We're going to, oh, were you guys, you were last ones. Go, Chris. Examples of things that are, that's a nice look for you, by the way. Examples of things in equilibrium. Go. Okay. Okay. No gravity. How many other groups came up with that one? Okay, that means we got more stuff. Go. Okay. Again, we're talking to different people. Go. similar to a pendulum, right? This one doesn't move or doesn't, who knows, right? There's something maybe a little bit different. All right. Talk to me about an isotonic solution. What does that mean to you? It's fancy. I mean, it makes them sound fancy, doesn't it? Guys, I need your attention up here and to listen to each other so that we can have one conversation. Ladies, put the Skittles away. It's too much now. You're getting distracted and you're distracting me. Go. Okay. So there's no change, right? Cool. Awesome. Thanks for chemistry. I haven't done chemistry for a really long time. What you got back there? I'm not. I don't even know how to spell those words. That's chemistry also, right? All right. Chemistry thing. I haven't done chemistry. Oh, is it bio? I asked and nobody responded. So how about if we do biochemistry? There you go. All right. So which of these 1, 2, 3, 4, 5 are the ones that we're really going to talk about today? Not the last two. You got it. Exactly. Maybe that one. I don't know. We're talking about things that when we're talking physics are in equilibrium. And that's important. That's the important thing, like in this thing. But that's not to say that it's not true here. Okay. The fun thing about physics is that it applies to all the other sciences. And so it is why an isotonic solution works that way, and why a fully catalyzed, I don't remember what you said, enzymatic reaction is what it is. Okay, I haven't been bio for a long time either. Okay, we good? So now I'm gonna tell you a story. You ready for story time? I'm trying to figure out who my story is gonna be about today. So story time with Miss Carveling. Here it comes. Josh, do you want the story to be about you? Sure. I feel like, okay. So Josh, you're gonna be one of the main characters. I need one other main character in this story. Another story. What's that? Okay, awesome. So TJ and Josh, here's the story. It's a true story. So TJ and Josh. So Josh has one of those. So different houses and different families have different kind of philosophies about how their homes are arranged. So like at my house, our furniture is really just in the same place all the time. That's just kind of how it rolls. Whereas the kids that I grew up next door to, like they were reorganizing their house like once a month. They would like whatever. Like it's just every family does things differently. I don't know if you guys know this about Josh's family, but they like to reorganize their house a lot. Okay. Is it? Yes. All right. So one time it was Josh was kind of the one in charge, and so he was like trying to figure things out. And he kind of had it all planned out, and so he called TJ up. He's like, "Hey, I need some help moving some stuff. Can you help me out?" Right? Okay. And so TJ comes over, and Josh and TJ are moving. They're moving coffee tables. They're moving chairs. They're moving all kinds of stuff. They're gonna move the couch. Now, I don't know. They've got really thick shag carpeting. True? No, maybe not. I don't know. We're gonna pretend like it's true. And there's a really big couch. It's the kind of couch that really it's not very safe to move with just one person, right? So we're gonna have a couple people, which is why you had to make a phone call. So they've got this couch and it's on one side of the room. It's got to go to the other side of the room. So what are they gonna do? What are they gonna do? Not gonna pick it up. That's too big. We're gonna push it. Yeah, we're gonna apply force. We're gonna push it. So life is good, right? So we've got. What color is this couch, Josh? What color do you want it to be? Brown? Judgy much? All right. So there's the couch. Okay. And TJ, what color do you want to represent you? Okay. And Josh, what color do you want to represent you? Can't be pink or brown. Okay. All right. So here's the force of TJ, and here's the force of Josh, and all is well. Okay. And they're moving the couch, and see, it's kind of appropriate that they're the ones that volunteered. Because sometimes they a little bit, right? And somehow, as they're pushing this couch across the room, TJ makes some sort of comment. And then Josh makes some sort of comment, and it gets to be a little off. Okay, and so anyway, things escalate pretty fast. So much so that instead of leaving or whatever, TJ's like, I'm not going to help you anymore. And indeed, not am I only not going to help you, but I'm going to actively keep you from moving this couch. I know, it was just, you guys, this is like reality TV at its finest right here. So this is what happens. First of all, anyway, little side, physics aside, right? You can't just do story tangents. Is this couch at equilibrium right now? No, it's not. Of course not. Where's it going? Which way is it going to accelerate? Oh, right, we're going to assume no more shed car, but we're going to just assume that it's so no friction or very low friction, whatever. So that it's pretty easy to move now. Okay, so TJ decides that he's going to actively prevent Josh from moving this couch that apparently has gotten larger over time. So instead of just helping this way, TJ's going to go around to the other side. He's going to be like, we're not going to move this couch across the room. It is not going anywhere. So TJ goes over here and he starts pushing this way. Oops, there we go. The force of TJ. So I'm not drawing a free body diagram. I want to be very clear. You guys with me here? Not drawing a free body diagram because, well, it's not free body diagram time. And Josh is standing over here. Now, I don't want to make any judgments about relative strength or whatever, okay? For the purpose of this story, because I get to tell the story, I'm going to assume that they have the ability to push with the same amount of strength. Now, question real quick. If they were pushing on each other, who would push harder if they were pushing against each other? The same, right? That's a what? Where's that come from? From what? Newton's third law, right? Force of TJ on Josh is the same as the force of Josh on TJ. It's third law. But now we're just pushing on the couch. There's friction against their shoes, so they're really just going to push, both pushing on the couch. We're going to assume that they push the same force. Okay? However many newtons of force TJ pushes with, Josh is pushing with the same number of newtons, not because of the third law, because they're both pushing on a couch, but the length of those arrows should be about the same. I was trying to make them the same. And not question. Is the couch at equilibrium? Yeah. It's not going to break. This is a high quality couch. Come on now. High quality couch is not going to break. How do you know that it's at equilibrium? Okay. Okay, so you're saying it is at equilibrium here. You said it was not at equilibrium here, right? We said it was not at equilibrium here because we have the two forces pushing in the same direction. And so it's going to accelerate in that direction, whichever direction that is. You're telling me it is at equilibrium here. How do you know it's at equilibrium here? The net force is 0. F net equals 0. So if I take the force of Josh and the force of TJ and they're the same magnitude, opposite directions, so that means that it's at equilibrium. Everybody cool with that? Okay. Not because it's Newton's third law of pair, not that, but because the forces are the same magnitude, opposite directions. Okay. You think that that's the end, but it's not. There's more. But wait, there's more. Here it comes. Okay. So TJ was really crabby, and so he moved over here. And then, so this was ugly, you guys. Like, they're just unhappy with each other. So here's what happens next. Josh is just upset now because, when I think Josh, I think that he gets really upset. Like, I feel like, I don't know that I've ever seen you upset, but I'm going to pretend like, okay. And so TJ's like, he's like, and he's like, and he's just like grabbing and grubbing. And Josh, and then he's like, ha. And so now this is what Josh does. He doesn't stop pushing. But because, that would be a different story. But so TJ's pushing like this. And Josh just takes a step to the right. And he's pushing with the same force that TJ is. So now, what's going to happen to that couch? Okay, so it's going to rotate. It's going to what? It's going to rotate. So my question for you is this at equilibrium? Well, if it was starting at 0, right? And so then Josh moves over here and he's pushing. Is it at equilibrium? It is rotating. What do you guys think? Gut feeling based on what the word equilibrium means. Look back to what it means. Is it balanced? Is it balanced or no? What do you think? We're going to say yes, we're going to say no, we're not quite sure? Okay, we're going to come back to that. All right, we're going to do a lab. I'm going to show you the setup, and then I'll explain to you what the lab is, okay? So we're going to walk over. So here is the assignment. It's very straightforward, and I didn't print out a piece of paper for you because you don't really need one. It says, given the setup that I was going to take a picture of, but I just showed you because that seemed faster, collect and graph data to determine a relationship between the force applied and the location of the application of the force. Right, so this is like TJ and Josh were pushing like this. Everything was hunky-dory, but then he stepped over here and then things got a little funky, right? So we're going to balance and figure it out. Location of the force relative to the balance point. One other piece of information is that those weights can actually hook together, so you can get lots of mass on one if you want. So you can change your masses a lot. Okay. Let's see. We've got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you get even number. So 9 groups. I've got 8 sets out there. I'll go get you one more set. You can go ahead and get started. Okay. You've got the rest of the period to work. It's like 21 minutes or something like that.